Let's be sure we know the meaning of some common pumping terms. You have probably figured out that a stroke is a forward or a backward movement of a piston. This is correct. A revolution is a complete series of strokes. For a simplex pump, a revolution is a forward and a backward stroke. A simplex pump makes 2 strokes per revolution. For a duplex pump, a revolution is a forward and a backward stroke for each of the 2 pistons. A duplex pump makes 4 strokes per revolution. The number of strokes per revolution equals 2 times the number of liquid pistons. A single-acting simplex pump makes 2 strokes per revolution, but only one discharges liquid. The other sucks in liquid. So a single-acting simplex pump makes 1 discharge stroke per revolution. But a double-acting simplex pump discharges on both the forward and backward strokes. So it makes 2 discharge strokes per revolution. And since a double-acting duplex pump makes 4 strokes per revolution, each of which discharges liquid, it makes 4 discharge strokes per revolution. Steam-driven reciprocating pump sizes are expressed in terms that require explanation. Sizes are expressed in such terms as 12 by 10 by 18 or 4 by 3 by 5. It's easy to remember what the numbers mean if you remember SOS, steam, oil, stroke. The first number is the diameter of the steam piston in inches. The second number is the diameter of the oil piston in inches. The third number is the stroke length in inches. A 12 by 10 by 18 steam-driven reciprocating pump has a steam piston 12 inches in diameter, an oil piston 10 inches in diameter, and a stroke length of 18 inches. It's time for another session in workbook number 2, exercise 9 this time. Understanding the terms we have discussed will help you to make certain calculations concerning steam-driven reciprocating pumps. One of the more commonly needed calculations is discharge pressure, pressure on the oil side. We'll call it P sub O in a formula a little later. Because the discharge pressure of some steam-driven reciprocating pumps is much greater than the steam pressure driving the pumps, you may need to calculate discharge pressure to determine whether it's safe to use a particular pump in a given piping system. In some cases, your concern may be whether the pump will put up enough discharge pressure. You can calculate the discharge pressure by the formula P sub O equals P sub S times D sub S squared over D sub O squared, where P sub O equals discharge pressure, P sub S equals inlet steam pressure, D sub S equals the steam piston diameter, and D sub O equals the oil piston diameter. Let's see how it works for a 4 by 3 by 5 steam-driven reciprocating pump when inlet steam pressure equals 120 psig. Remember SOS, steam, oil, stroke. Steam piston diameter is 4 inches, and oil piston diameter is 3 inches. Substituting numbers in the formula, P sub O equals 120 psig times 4 inches squared over 3 inches squared. P sub O equals 120 psig times 16 over 9 equals 213 psig to the nearest whole number. Where great accuracy is required, such factors as exhaust steam pressure and pump suction pressure must be taken into account. But the formula is accurate enough for most purposes. Note that it was not necessary to know the specific gravity of the liquid being pumped. The discharge pressure of a steam-driven reciprocating pump is the same for any liquid. But discharge heads are different. Head equals psig over the product of 0.433 times specific gravity. The discharge head for this pump would be 492 feet when pumping water, 410 feet when pumping brine, and 615 feet when pumping kerosene. The discharge pressure of a steam-driven reciprocating pump is the same for any liquid, but discharge head varies inversely with the specific gravity of the liquid being pumped. You may also need to calculate the capacity, pumping rate, of a steam-driven reciprocating pump. Common capacity units are gallons per minute, abbreviated GPM. You can calculate pump capacity by the formula C equals 0.785 times D sub O squared times L times S over 231. Where C equals pump capacity in gallons per minute, D sub O equals oil piston diameter in inches, L equals stroke length in inches, and S equals number of discharge strokes per minute. Suppose the 4x3x5 pump we've been talking about is a duplex, double-acting pump making 120 strokes per minute. A duplex, double-acting pump discharges on each stroke. This pump makes 120 discharge strokes per minute. Substituting numbers in the formula, C equals 0.785 times 3 squared times 5 times 120 over 231. C equals 18.4 gallons per minute. This is a close approximation to the pump's capacity if it were 100% efficient. Steam and liquid leaks, internal pump valve leaks, and friction all reduce efficiency, often to as low as 50 or 60%. So we must consider our calculated figures, discharge pressure, head, and capacity, as approximations. They are nevertheless useful in working with pumps. Now turn to workbook number 2 and complete exercise 10.